Okay guys, welcome to it's not 9, it's 10.1. And in this video, we're going to be talking about something that's called mole ratios. Just to review, some of the things we learned in Unit 8 is we learned about two really important conversion factors. We learned that when you have 1 mole of a substance, we learned that that will mean that you have 6.02 times 10 to the 23rd items, right? And when I'm talking about items, I'm really talking about atoms, and molecules. Those are the items that we use when we're doing chemistry, okay? So 1 mole will always equal this many atoms or this many molecules. We also learned that you could have 1 mole of something and you could figure out how much it weighed by looking at the molar mass on the periodic table. Okay, molar mass is always in grams and it's the number underneath the symbol. Okay, so molar mass will tell you how much mass is in a mole. And then Avogadro's number will tell you how many items are in a mole. Okay, so we learned those two. We're going to learn a new one. It's called a mole ratio. And a mole ratio will tell us how many moles of one substance will equal how many moles of another substance. I'm going to put question marks here because this is one of the conversion factors we actually have to find these numbers for. They're not given to us. So this is what is known as a mole ratio, and I'm going to walk you through exactly how we set that up and how we use it, okay? So let's take a look at this question here. This question says that it's not actually not a question, it's an equation, okay? In this equation, we see these big numbers here. These big numbers, if you remember from last unit, are called coefficients. Now, can you guys remember what a coefficient stands for? Anyone? Coefficient is the number of moles. Okay, that's what we use it to stand for in chemistry. So if I was to read this out, I would say I have 2 moles of water, and it's going to form 2 moles of hydrogen gas and 1 mole of oxygen gas. Now, why did I say 1 mole? Well, if there's not a number right here, we always assume that that number means 1, okay? So these coefficients stand for our number of moles. We can use these coefficients in a mole ratio. And I'll give you an example of how to use that. So let's say I gave you guys a question and I said, let's say I said, how many moles of O2 are made from 6.2 moles of water. Well, in our equation, we used 2 moles of water. In this equation, we're not using 2 moles of water, we're using 6.2 moles of water. So I'm going to set up my given with the only number that I'm really given, and that's 6.2 moles of water. That's my given over 1. I'm going to write out our thought pattern here. Basically, I'm given moles of one substance. I like to call this moles of A. Okay, for us, A is going to be water. A is always going to be your given. So if you're in moles of water, is your A. If you're given moles of oxygen gas, then oxygen gas is your A. So we're in moles of A. We want to convert to what? We want to convert to moles of oxygen. So moles of B is oxygen. So we're in moles of A, which is water, and we're wanting to go to moles of B, which is oxygen and gas. So we have to use a conversion factor to help us get there. Which one of these 3 conversion factors that we've learned about, which of these 3 right here, can get us from moles of A to moles of B? Okay, you should see that this one right here is not going to work. The middle one's not going to work because it gets us to atoms and molecules. We don't want that. We want moles of A to moles of B. The bottom one's also not going to help us because that gets us to grams. The only one that helps us is the new one we're learning about called a mole ratio. A mole ratio will get us from moles of A to moles of B. So I'm going to rewrite this out, and instead of putting A and B, I'm actually going to write out the chemicals that I'm using, okay? So my conversion factor I'm looking for is moles of water. How many moles of water will equal how many moles of oxygen? Okay, do you see how Water was my A, and I just kind of put it in there, and then oxygen was my B, and I just put it in there as well. What I need to find is how many moles of oxygen and how many moles of water will equal each other. Well, I know that from my balanced equation. My balanced equation tells me that 2 moles of water equals 1 mole of oxygen gas, or 2, really doesn't equal, but it's like 2 moles of water will be used to form 1 mole of oxygen gas. So I now actually have my full conversion factor. I know that 2 mole, that's a horrible 2, that's like the worst 2 ever. 2 moles of water are used to form 1 mole, that's a 1 by the way, of oxygen gas. So this is the conversion factor I'm going to be using. Okay, I basically took this one and I filled in my compounds, water and oxygen, and I filled in my numbers, 1 and 2. Okay, straight from the balanced equation. So this is what I'm going to use. Oh, where'd my mouse go? Okay. This is what I'm going to use to fill in this fraction. So we always have to ask ourselves, what is going to go on the bottom of the fraction? This is going to we're kind of review everything we learned from the very, very first unit of this semester, and that's whatever unit's on the top has to also be the same unit on the bottom. So since we have moles of water on the top, we know moles of water has to go on the bottom. Okay? Which part of this conversion factor has moles of water? You should have said this part, right? This has moles of water. So 2 moles of water goes on the bottom. The other part of my conversion factor is 1 mole of oxygen. That is going to go on the top. 1 mole O2. Now I can just solve for my problem. Moles of water and moles of water cancel out. And then you multiply the top and multiply the bottom. So if I multiply the top, I have 6.2. If I multiply the bottom, I have 2. The second step after you multiply the top and multiply the bottom is you divide them. When I divide them, I get 3.1. Now, what's my unit? Whenever you're trying to figure out your unit, look at the last unit at the very top. Moles of water and moles of water has been canceled, so the only thing I'm left with is moles of oxygen. So I will produce 3.1 moles of oxygen if I start with 6.2 moles of water. Okay, let's go ahead and do a guided practice problem. This one is going to be a little bit harder, and I'll tell you why. It's because I didn't give you the reaction. So before starting, always write the reaction and balance it. So step 1, write the reaction. Step 2, balance the reaction. Okay, so let's write the reaction. I'm going to highlight my products first. We know carbon is a product, or not, did I say product? I meant reactants. Highlight your reactants. Carbon is a reactant because it says it reacts. What's it reacting with? It's reacting with sulfur dioxide. So let's draw out our reactants first. Carbon is a reactant, right? I just said that. So here's carbon. It says it's a gas, so I'm going to write that out. It reacts with sulfur dioxide. So sulfur is S, oxygen's O. It says dioxide. This is a huge throwback. Prefixes are used for covalent compounds. So if it gives me prefixes, I actually don't have to even out the charges because it gives me the formula. It tells me how many oxygens I need to use. And it said it was solid, so I'm going to write S here. Okay, so that's my reactants. Well, what are my products? It says I'm producing, so that's my hint that I'm about to hear what my products are. I'm producing solid carbon disulfide, and I'm producing carbon monoxide gas. So let's write out our products now. I draw my arrow, and then I'm going to write out my products. Carbon and sulfide is sulfur. The di is a hint that there's 2 sulfurs. Again, that's a covalent compound, and so I don't really have to even out charges. It says it's a solid, so I'll put an S there. And I am also producing something called carbon monoxide. Again, I see a prefix, carbon, and then monooxide means just 1 oxygen. And it says it's a gas, so I'll write that out. Okay, So I've done the first part. I've written the reaction. Now I have to balance the reaction. It says that if I used 6.3 moles of carbon, that's my given. I'm going to automatically write that out. 6.5 moles of carbon. And now I have to think, what am I looking for? I'm looking for moles of carbon disulfide. So really, I have moles of A. I'm going to moles of something else. That means moles of B. So what conversion factor do I need to use? Well, obviously, hopefully you know now that we're going to use the mole ratio conversion, right? Our mole ratio conversion is moles of A, which what's A in this equation? A is always the given. What are we given? We're given carbon. So we're trying to find moles of carbon and then equals moles of B. That's the conversion factor. So what's B in our reaction? B is what you're going to. It says moles of carbon disulfide. So carbon disulfide is our B. So now we just have to find what numbers we're going to use for this conversion factor. All we have to do is look at our balanced chemical equation. We have 5 moles of carbon that's used to produce, and there's not a number here, so I'm going to assume it's 1. So we write here 5 moles of carbon is used to produce 1 mole of CS2. So I'm going to use this conversion factor in my formula. Since moles of C is on the top, I want moles of C on the bottom. There's 5 moles of C. Just plugged that sucker right in there. And then I'm going to moles of CS2. And this guy right here tells me there's only 1 mole of CS2. So I plug it in right there. So now all I have to do is multiply the top, which is 6.5. I'm going to multiply the bottom, which is 5. Oh, I'm sorry. I think I messed up one of my numbers. This says 6.3, and I guess I wrote 6.5, so this should really be 6.3. That's a horrible 6.3. It looks really scary. Okay, so 6.3 divided by 5 is, I don't know why I'm drawing that line. Okay, it's 1.26. So what does that number stand for? Well, I got out of moles of carbon, and I'm in moles of CS2. So that's my answer. Moles CS2. Okay, if we were to use the same equation, so the same equation that I have above, and it's giving me 7.2 moles of sulfur dioxide, and it wants to find out how many moles of carbon are needed. This is going to be my given. So I write 7.24 moles of sulfur dioxide over 1. Okay, I'm going from moles of A, which is sulfur dioxide, to moles of B, which means I'm going to use the same conversion factor I've been using, mole ratios. So how many moles of an A is sulfur dioxide is used with how many moles of carbon? So I have to find these numbers here. So I'm going to look back at my balanced equation, and it says that there's 2 moles of sulfur oxide that react with 5 moles of carbon. So those are the numbers I'm going to plug in to my conversion factor. So what do I want to go on the top and what do I want to go on the bottom? Well, moles of SO2 are on the top. So I want moles of SO2 on the bottom so they can cancel out. So that means 2 moles of SO2 goes on the bottom, which leaves me 5 moles of C to go on the top. Okay, when I multiply the top, I'm going to get 36.2 moles of C divided by 2, which gives me, when I divide them, 18.1 moles of carbon. So, and again, I know my unit's moles of carbon because I canceled out of moles of SO2 and I was left with moles of carbon. So now what I'd like y'all to do is to do the on your own problem here at the bottom. It's going to require you to write out the equation and balance the equation before you actually solve the problem. And that is it for 10.1. Have a great day.